So, welcome everyone. Welcome to the 10th week of discussion session of the course Finite Element Method, course offered by NPTEL. The course instructors of this course is Professor Vishwanath Banerjee and Professor Amit Shah, and myself, Asif Raza. I'm a teaching assistant. I'm a PhD scholar from Department of Civil Engineering, IC Bangalore. So, today we'll be discussing uh, questions uh, relevant to assignment number 11 first, and then we'll discuss the questions of assignment 10, the solution of assignment 10. So let's start. So first of all, can somebody confirm whether my screen is visible or not? Yeah, thank you. So okay, so the first question, this question is relevant to assignment number 11. So the question is, suppose there is a cantilever beam of length L, thickness H, width V. It's subjected to a point load at its free end. According to Euler-Bernoulli beam theory, what of the following option holds true for bending of beam? The first option is bending deformation is negligible, but significant amount of shear deformation arises. Second option, shear deformation is negligible, but significant amount of bending deformation arises. Third is both bending and shear deformation are negligible. And the fourth option is bending and shear deformation arises significant amount. So Abdullah and Rafal has given their views as option B. What about Jis? Yeah, Rafal, you want to add something?
I want to answer. I want to ask a question here.
Yeah, yeah. Go
What
for it.
what if you have if we have a cantilever beam
This
with
is a
point load
cantilever beam.
cantilever beam with point load at the end? Yes. In
Yeah,
the Euler-Bernoulli theory, should we have shear forces uh, in the equation if we use a theory of elasticity for solving this problem?
I am not connecting with you what you are saying,
Can
what
can
you're
I
trying.
can I write? Can I write?
Okay, let me give the answer for this question, then you can add on. So, as this has also said the option B. So, I'd say, yeah, everyone is correct. That correct option is option B. So now Rafal wants to add on this, like he wants to ask something. So please go for it. Yeah, Rafal.
I'm asking the following question. For instance, we have a cantilever beam. Yes, cantilever beam with point load at the end.
Yeah, this
Usually,
question.
usually if we talk about Euler-Bernoulli beam theory, we are talking about bend,
Bending.
pure
Yeah.
bending.
Yes.
But if we use point load at the end, we have a force shear force at each section. So in this case, we need to use something that describe shear forces. So if we have a point load, we need to have some shear there. Can we here talk about Euler-Bernoulli beam theory if shearing are there? This is not clear for me because in theory of elasticity, sometimes some shear are presented even in Euler-Bernoulli theory, and this is not clear for me because in classical strength of material course we are not dealing with shear even if we have a point load?
Okay, so there are two things into play here. Uh, there is a transverse force present. There is a transverse force present that is point load at the end, which uh, uh, so pure bending case is not that we are inducing a bending moment, rather than we are inducing the bending moment using the point load at the end. Now you're saying if we are saying providing point load at the end, then shear is coming into play. And if shear is there, why are we using Euler-Bernoulli beam theory? My question, whether I got your question, Rafal? Rafal, are you there? So Rafal, I said if we are
I
using
wrote. Yeah, sorry.
Euler-Bernoulli theory with point load, can we talk about Euler-Bernoulli? Because we cannot talk about cell. Okay, so in this regard, I would say uh, we cannot talk about shear stresses in Euler-Bernoulli. Okay, I'll say question is this. We are applying point load here. So if we just take x from here, x equal to 0 to x equal to L, or what do we normally write? Bending moment as Cx, while shear force we write as, sorry, yeah, and shear force as P.
Yes, it is correct. Yes, I'm okay with that. But if we have a P force, then we have a shear deformation. Is that correct?
No.
This is parabolic tau along the section.
Okay, so uh, if I take a particular section, because shear force is constant all through, right? So if I take a particular section, say dx, okay, now we have this section. I'll just write here. So in the left hand side, it will be P. The right hand side, it, uh,
P over A.
uh, it would be P. P, P. Yeah, you're saying?
Yeah, I'm okay with that.
And there would be some movement. Uh, there would be some moment here. So finally, there would be some bending moment in this section, but the shear force will cancel it out. Because if you see, uh, my shear force is constant all throughout with this section. So this at this point, whatever my shear force is, the same is there in this other point. So in this section, the dx, there won't be shear deformation into play.
Um, I believe I'm not. I don't. I'm not agree with you in this case. We have a shear force. We have a this distribution along the parabolic
See,
distribution of the tau
no,
along the section.
whether mm, because I don't think whether layers will sleep amongst each other when the shear force is same all throughout.
Look, can I share my screen for a minute?
Yeah.
Uh, it will be some Russian there, but I believe you will see the equation we need here. I just don't understand this point. Euler-Bernoulli, no stress, okay? Euler-Bernoulli, it's no stress. It will be clearly stated in the beam lecture. And we have now agreement that we have no shear in Euler-Bernoulli. They are negligible. But if we have point load, we should have stress there because of this Q. I'm sharing my screen, and today
Yeah, you haven't said your screen yet.
yes, look, today I'm sitting in mess in my head because look, this can you see my screen?
Yes, yes.
Uh, what I'm see today when I consider this problem. Look, always tau is presented when we have a shear force. When we have transverse force, always there is tau distribution along y, and it is parabolic. It is this well-known distribution of the tau
Shear.
xy. Yes, and this is my question. How we can use simultaneously Euler-Bernoulli and point load? Can we just neglect this? Can we assume that this is zero, is negligible, and use only distribution as sigma x is equal to p over L minus x divided by E? Can we just neglect this in Euler-Bernoulli?
See, tau xy is equal to, can you just iterate it with your, like, tau xy is equal to minus,
It's just some constant. Minus b minus d over 2y squared.
no, but still it's not dimensionally correct, right?
It depends on constant b and d. Of
Yeah.
course, it's
So,
megapascals.
can you just tell me what are B and D?
Look, this is a theory of elasticity book, and they just checking this stress function with this condition. I can tell you the formula where you can recognize this formula. It is its formula. This is parabolic distribution along.
Yeah. Shear stress.
You
Distribution.
know this formula. This is a parabolic distribution along section, and look, Q is here is a transverse force along this section. So my question is, can we? I don't understand when we're talking about Euler-Bernoulli beam. Can we simultaneously consider problem with point load, because point load produce shear force, and therefore we have a shear distribution along this section, and we cannot talk about Euler-Bernoulli and shear force simultaneously. I don't. This point is not correct for me in this question. And it's not clear. Sorry, this point is not clear.
I get your point that uh, first thing first is like when Euler-Bernoulli, what is the difference between Euler-Bernoulli and other theories like Timoshenko is when Bernoulli focuses only on weak formation. When we consider formation, then other things, but in Euler-Bernoulli itself, like we do consider saying shear stress distribution, is it?
When we talk about Euler-Bernoulli infinite element method in this course, there was a lecture devoted to Euler-Bernoulli beam, and there in this lecture, it was demonstrated that if we consider Euler-Bernoulli, we have this gamma deformation, this angular deformation equal to 0. So there's no shear stress in Euler-Bernoulli.
Yeah.
The lecture said that lecture. I can
Okay.
send you to the lecture where
Yeah.
it was stated.
Yeah. But the further question is regarding Euler-Bernoulli itself.
If we have transverse force,
Yeah.
it means that we have shear stress there. So if we have shear stress there, it is not in good relationship with Euler-Bernoulli, because shear stress if we have shear stress, we have shear deformation. If we have shear deformation, there is no Euler-Bernoulli, so they are not in friendship with each other. If
No,
we Euler-Bernoulli only for pure bending. If we have point load, we cannot talk about pure bending anymore. We just can say we neglect shear force. This is my point here.
yeah. So thing is,
Excuse me.
yeah, Abdullah.
Yeah, I think as I understood that yes, there will be shear stress, of course, but the shear deformation, this is what we neglect. Although
Yes.
practically it is there, but as Euler Bernoulli, we just neglect it because it's too little and too small. The major effect is because of the bending. That's why. But when the depth of the beam become more, we go to the Timoshenko beam because the shear deformation will be more or larger. I don't know if I got you. This is what I got it.
Yes, you got. Abdullah, we don't neglect shear stresses, but we neglect shear deformations.
Exactly.
Okay, it makes sense. Thanks.
Welcome.
Okay. So one more thing I wanted to say that whether if we have a shear force, does it necessarily mean that deformation would be there? Like shear deformation would be there. Like I
From my
can provide.
perspective, we have a constitutive equation. If we have tau, we have angular deformation. Am I
Like
right?
come again.
Look, tau is equal to shear modulus multiplied by gamma.
Yes.
So if you have shear, if you have a non-zero tau, we have non-zero gamma. But Abdullah said that we need to neglect that. I need to check that because I cannot say that.
No, I'm not talking about stress though. I'm talking, uh, say, this is one thing. I can provide a bending moment only using shear force, like this couple. Uh,
Yeah.
this can induce what? The effective transverse stress, transverse force is, okay, sorry. Effective transverse force is zero in this uh, element, but what will happen to the bending? It will induce bending, right? Even though I am providing transverse force in this element, but do you think there would be any transverse stress?
In this case, I believe yes.
How?
Uh, we just divide this force along the we divide this force for
So if I
area. Yes.
take a particular section, say this, so what will be like now the section? If I take the left one, I had the force like this, then
You are you considering equilibrium there?
so finally equilibrium would come into play, isn't it? Like I did this because this is fixed for the case of cantilever.
Yes.
So if
If
I
we have just one force point mode, we
reactant,
definitely have a moment in this section, and we
yes,
definitely have a shear force. If we use constitutive equation, we need to have elongation in layers and shear deformation of the section because we have a transverse force.
okay. So
In a pure bending condition, this force is equal to zero in a pure bending condition. So
transverse
if we
force.
have a my answer is yes. In this case, we have a shear deformation and uh, shear stresses because we have a force there. We just divide this force along the area and we produce a shear deformation.
Mm, still, how should I make it clear? Because in the pure pending case also, you can uh, remove the couple, like remove the bending by inducing two transverse forces, which is indirectly providing a couple in that section. So still don't get. In this regard, I would uh, say iterate what Abdullah was saying, that uh, the, we don't completely, we are not saying whether the shear stress won't be there in this uh, like problem, but we neglect the shear deformation because it's too little in comparison with bending deformation. So when the thickness of this element has more dominating effect, then shear deformation becomes more dominant as compared to bending, or becomes comparable. Then we consider shear stress, also shear deformation. Then we switch on to different uh, beam theories. Anyways, I'll try to explore much about it so that I can resolve your doubt in this. Okay, moving on to the next question.
Okay, thank you.
Yeah. Uh, so this is next question. Suppose there is a cantilever beam and it is discretized with Q4 element. Q4 element is four-noded quadrilateral element. What option for the following statements is correct during the bending of that beam? And the first statement is undesirable spurious bending energy will be introduced within the element during numerical formulation. Second option is statement is undesirable spurious shear energy will be introduced within the element during numerical formulation. So the options are first statement is true but second is false. Second option is second is true but first is false. Third option is both first and second statements are true. And the fourth is both these statements are false. So guesses. Abdullah has given answer option B. Others? So I think Rafael will have a doubt in this as well because it's in continuation. It's similar to the earlier question where he was confused with the shear and bending. So correct answer is option B only. So what is spurious? First of all, spurious is uh, like fake thing. It's not actually present, but it's getting generated. So, mm, so how should I say it? Mm, mm, uh, as you all not complying, but in the bending of beam case, there is no shear deformation, only bending deformation is there. But when we consider Q4 element for this problem, what will happen if you bending case like um, when if I'm making it correct, the bending problem. So this is coming back, so this extends and this contracts. Okay, so uh, This is not my expertise though. So this is my Q4 element. In the bending, the what should it happen is this should, in the pure bending case, it should go like this. Okay, so uh, mm, should go like this, and uh, mm, mm, yeah, okay, I remembered. So this is the case. It should the element should be like this. Okay. Earlier the element was this. It should be like this because the upper thing would contract and the lower thing will expand. Would be the case. And the points at which we are calculating are supposed inside. So normally the points are like this. Rather, it should be like this, like this. So effectively, what we are getting is the shear at the neutral axis. We should not get. Actually, we are calculating everything shear, strain, energy. It should cancel it out, but we will get a shear energy contribution if you are calculating here and here and here. Like at each data point, we calculate shear energy, bending energy. So if we had calculated here this, we would have gotten like everything would get cancelled it out each other. This would have been equal to zero, and only bending energy should be there because it's a pure bending case. But what will happen in this case when we take Q4 element? Then the spurious shear energy would come into play, and this US would be not equal to. I am still. It's still a vague thing I have provided. This is not my field of expertise, so I can't help much in this regard. Like the problem in this domain is shear locking, volumetric locking, and hourglassing. These three are like prominent when we are considering computational aspects by problem. So it's a bit difficult for me. So sorry for that. Okay, so I'll move on to the next question. Uh, this is like solution directly solving how we need to solve this. So suppose there is a cantilever beam of length L, thickness 2h, width B is subjected to a point load at its free end. The beam is discretized with single element and linear polynomial is used for approximation of primary field variable, displacement and the slope. What will be the potential energy of this beam? The question is what will be the potential energy of this beam? Consider total strain energy is equal to UB plus US, where UB and US is bending and shear strain energy respectively. So the problem is this we are given with an element S, where theta1, W1, theta2, W2 are my degree of freedom. Width is B, depth is 2h, EI is my E and I are the respectively Young's modulus and moment of inertia, second moment of inertia. So let's try to solve it. So first thing first, we're given the approximation of primary field variable W. So displacement, we need to take. So let us see here that x is starting from here, right? And we know this is a cantilever case. So theta1 equal to 0 and W1 equal to 0. So if we see W2 will be greater than W1 and theta2 would be greater than theta. Linear approximation will give me what? W of x, like if you take at any section x. So W of x would be equal to what? X by L times W2. So that at x equal to 0, it would be 0. At x equal to L, it's W2. Okay. Similarly, theta of x would be equal to x by L times theta 2. So the equation it says it's a linear polynomial approximation. Okay. Now, what will be my second moment of inertia? It's b by 12. So weight is b, depth is 2h. So 2h cube by 12. It would be what? 8bh cube by 12. Okay. Can simplify it further. This would be equal to bh cube 2 by 3. Now, potential energy due to bending. So, what will be the potential energy to bending? It will be equal to EI by 2, 0 to L d theta by dx whole square dx. Okay, this is equal to E. I is 2 by 3 dh cube to 0 to L d theta by dx. So, we have theta here. D theta by dx would be theta 2 by L. So, it will be theta 2 by L whole square dx. Let's simplify it further. EBH 2 by 3. It will be, it's a constant, theta 2 by L. So, x will multiply theta 2 by L whole square and x dx, it will be L. So, ultimately, it's equal to EBH cube theta 2 square 3L. This will be US is equal to US is shear strain energy, and we are given with the uh, shear modulus as Ks. Sorry, yeah, shear modulus as G, and Ks is the shear correction factor. So it will be equal to Ks GA by 2 0 to L dW by dx minus theta square dx. So this will be equal to Ks G. A would be what? B times depth is 2h. 2 0 to L dW by dx is W2 by L. Theta of x is x by L theta 2 dx. Let's write it further. Ks G dh 0 to L, this L whole square plus minus 2 W2 theta 2 x L square plus x square theta 2 square L square x square dx. So the simplification will give me Ks G B H. So integrating it will get W2 by L whole square. It will be x minus 2W2 theta 2 L square. This will be x square by 2 plus theta 2 square x cube by 3 L square. The limit from x equal to 0 to x equal to e. So it will give me s is equal to kgph. It will give me this will be equal to w2 square l minus l square by 2 l square get cancelled out. It will be w2 theta 2 plus L cube. This will be L. This is theta 2 square L by 3. Okay. So let's see what does it matches with. So first thing bending is EBH cube theta 2 square by 3L. EBH cube theta 2 square by 3L. 3L is this EBH cube theta 2 square by 3L. Yeah. So this is okay. And the square was times GBH, then W2 square by L. Okay, so L square was taken out. If I take it out, KS, GBH, L square, it will be equal to W2 square by L square. Sorry, W2 square L times L minus W2 theta to L square. And this will be equal to theta square. L cube by 3. W2 square L minus W2 theta 2 L square plus theta 2 square L cube by 3. Yeah. The correct answer is option 3. Okay. I hope nobody has doubt in this question. It's simple, just first approximation of Rafael, you just said plus. Okay, okay. Yeah, thank you. We'll move on to the next question. First question is, in case of selective reduced integration scheme for bending of a thin cantilever beam, what of the following option is correct? Okay. The first option is shear locking can be avoided by taking full integration for bending stiffness and reduced integration for shear stiffness. Second second option is shear locking can be avoided by taking reduced integration for bending stiffness and full integration for shear stiffness. Third is shear locking can be avoided by taking full integration for both bending and shear. And fourth is implementation of selective reduced integration does not have any effect on shear locking elimination. So option Abdullah said option A. Others, yeah. So answer is option A. As you have already studied that uh, on taking full integration of the bending stiffness, on taking full integration for bending stiffness, shear locking is already avoided. We need to take care for shear stiffness, and to take care of that, we use reduced integration scheme. Okay. Next question is, what should be the rank of element stiffness matrix for a Q4 element if reduced integration scheme is followed? What should be the rank of element stiffness matrix? Abdullah is given option B. Others? Rafael don't know. Okay. Okay. I'll just tell you it's option B only. How's it? So first thing, you know what's the Q4 element. So how many degree of freedom it has? 4 into 2, it's 8. Okay. So to find the rank of the stiffness matrix, like uh, 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 initially, okay, initially, uh, the stiffness matrix will have what 8 by 8. Yeah. To find the rank of this element stiffness matrix, we need to remove first rigid body modes, and rigid body modes in this case would be equal to what 3 ux uy and theta, right? And there are two hourglassy modes. I hope this thing has been told in the lecture. So to find the rank will be equal to 8 minus 3 minus 2, and that will give me 5 minus 2 is 3. So the answer is 3. Okay. Moving on to the next question. Which of the following options is incorrect? It's a question regarding again Q4 element. So first statement is, for a Q4 element, there are three deformation modes for which strain energy is constant. Second option is for a Q4 element, there are three rigid body modes for which strain energy is zero. Yes, the constant. For a covalent, there are two hourglass modes for which strain energy is zero. And fourth is rank of element stiffness matrix is a number of degrees of freedom minus number of rigid body modes. So, out of these four statements or options, which of the following options is incorrect? Rafael has said option C. Um, and Abdullah is also option C. Yeah, so you guys are correct. Correct answer is option C only. Because this statement is incorrect. Correct statement is for the Q4 element there are two hourglass modes for which strain energy is not equal to zero. That's why strain energy is present. Okay. Uh, Next question. How many numbers of rigid body modes exist for a 3D brick element? This should be quite easy for you all. How many numbers of rigid body modes exist for a 3D brick element? Options are 3, 6, 8, 9. Okay, Abdullah said option C. Others? C, right? No. C. Then Rafael said answer 6. This option B, Rafael option B. Abdullah said option C. Yeah, Abdullah, can you unmute yourself and why? Can you just tell me why you are saying it's option C?
Actually, this C for the previous question. This question I didn't answer.
Oh, okay. My bad. Yeah. Okay. So everyone, this and Rafael said option B. Yeah. So you guys are correct. The answer is option B. And what will be those rigid body modes? UX, UY, UZ, like constraint in the displacement in the X, Y, Z, and similarly theta. Okay, so let's move on to the next question. What of the following options is incorrect? Please do look at question says. What of the following options is incorrect? First is use of lower order element. Lower order element cannot efficiently approximate pure bending problem. Second statement, higher order element can be used for accurate approximation of pure bending problem. Third is incompatible modes can be used in lower order element to approximate pure bending curvature. And the fourth says that all the above statements are false. Rafael said option A, Abdullah, and this has said option D. Uh, in this regard, Rafael, can you unmute yourself and tell me why do you think only option A is incorrect, because I can see myself that A and B are like, if option A is incorrect, then option B would again comply with that.
I thought I'm sure about A only, so I answered A.
Okay, okay.
A is this was the goal of the lecture to show that we can use actually a lower order element to efficiently approximate. So we use that. So it's then correct. But higher order element, I don't know. Incompatible modes, I also don't know.
Uh,
So I answered A.
okay, okay. So, to let you know, all the statements are incorrect. Yeah. Regarding the first statement, use of lower order element, it says cannot, but it can efficiently approximate pure bending problem. Regarding the second statement, higher order element can be used for accurate approximation of pure bending problem. So again, see, if we ask, uh, like, it's a other side of the coin. I feel it's the other side of the coin of option A. So that if that is not correct, then this will also be not correct most probably. So this is also incorrect statement. Higher order element, normally lower order element can are used for accurate approximation of pure bending problem. And the third statement is incompatible modes can be used in lower order element to approximate pure bending curvature. So this statement is correct. Sorry, incorrect. Okay. Okay. Moving on to the next question. Okay. So let me option D. This question, I think you guys would be knowing quite efficiently. The question says, what option for the following statements is correct? First statement, volumetric locking in a body can be observed if its Poisson's ratio is close to 0.5. Second statement is volumetric locking in a body can be eliminated using only full integration scheme. So options are, first statement is true but second is false. Second option is second is true but first is false. And third option is both are true while fourth option says both are false. So let's okay. Abdullah has given his answer. What about others? Okay, I'll just say yeah, option A is correct. Uh, the first statement is quite correct. Volumetric locking in a body can be observed if its Poisson ratio is close to 0.5. Volumetric locking, second statement, volumetric locking in a body can be eliminated using only, this is quite wrong. So we can use selective reduced integration too. Okay. Okay. Moving on to the next question, last question relevant to assignment 11. So, in case of B bar method, what option for the following statements is correct? First statement, the strain displacement matrix is decomposed into volumetric and divertoric part. Second is volumetric locking cannot be eliminated with B bar method. So, options are, first statement is true while second is false. Second option is second statement is true while first is false. Third statement both are true. Fourth statement both are false. One thing we can see is like, uh, first and second statement, it's contradictory in one sense. Okay, no problem. Abdullah said A but not sure. Yeah, correct answer is option A. So if you are sure in this regard, strain displacement matrix is decomposed in volumetric and divisory parts. And in B bar method, we are decomposing into volumetric and divisory part in order to eliminate like this volumetric locking. So yeah, volumetric locking can be eliminated with the bar method. Okay. Now let's move on to the questions relevant solution of assignment 10. I'll just yeah, Abdullah wants to say something.
Actually, can we go back to the question related to the energy you calculated
Okay.
at UB and US? Can you just like summarize like what happened here? Because
Okay. The question asks what will be the potential energy of the beam. So we need to find the potential energy of the beam, and that is due to bending and shear. So to calculate bending, okay. So, and one more information, it is said in the question that first of all, what are my degrees of freedom? W1 theta 1, W2 theta 2. Now W and theta both are question says that we need to use approximation function as a linear polynomial. Okay, so we know one thing, W1 and theta 1 would be 0. So theta 1 W1 has been made 0. Now approximation, like at any point x, if I consider W of x and theta of x, so what that would be? That would be equal to x by L times W2. So this justifies, like when x is 0, it will be 0, and when x is equal to L, it will be equal to W2. Similarly for theta. And then we calculate second moment of inertia, that is BdQ by 12, where B is my width and D is my depth. So here B and depth is 2h. So we substitute that and we get 2 by 3 bh cube. To calculate bending energy, it's equal to EI by 2 integrated in this domain d theta by dx square dx, and d theta by dx would be equal to theta 2 by L, cos theta 2 and L are the constants, and x is what is changing in this domain. So solving that will get bending energy is this. Shear energy, to calculate shear energy, this is shear correction factor, because along the section there is a different shear energy. Sorry, yeah. So to correct that, we use shear correction factor. This is a shear modulus area. So KSGA by 2, we need to integrate the domain, and the function in consideration of the integration is dw by dx minus theta. So square dx, and rest is just substitution and solving it. So bending energy, shear energy, and this is due to the point loads P times W2. Is it okay? Okay, so now moving on to the questions solution of assignment 10. This is quite easy. This was discussed in last session also, so we can directly move on. Uh, Answer was option A. Now, question is next question is uh, suppose we are solving a circular torsion problem in FEM and we found the shear stress distribution across the radius. Which one of the following is the correct shear stress distribution? So I think you guys already know the correct answers, but yeah, let's take the correct answers quickly. Yeah, answer is option A. And why is it like A linearly dependent on this radius? Okay, let's move on to the next question. This was also already discussed, and answer was option A. Yeah, this question is good. The question is, suppose we want to construct the shape function of the cubic triangular element. In the session, I asked a different. It was a different element. I think It was quadratic. I think. Uh, so, what will be the approximation function to be used to construct the shape function? Yeah. So, meanwhile, I'll just draw the Pascal's triangle. You guys can give your answer. Yeah. So, okay. The question talks about cubic triangular element. In cubic, how many nodes will be there? 1, 2, 3, 4. So 1, 2, 3, 1, 2, 1. Total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be the one. And yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And every polynomial is there. Yeah. So correct answer is option D only. Okay. This was quite easy. Yeah. This question also I discussed. This the question which I discussed here there. The coordinate was P2, 2. Question change only by just changing the coordinate to 1, 1. So the answer pertaining to this question, I will just say the question is: there is a right angle triangle with coordinates of vertices shown in the figure. What will be the area coordinate of the point P in triangular coordinate system? The triangular coordinate system is that area coordinate system. Rafula said its answer is option B. Yes, that's I think if I remember right, I think it's option B only. Let's find it. Let's better find it quickly. So 1, 2, 3, 0, 0. We have 5, 0 here. Here we have 0, 4. P as 1 comma 1. So if I draw, I'll write A1 here, A2 here, A3 here. Area of the old triangle is half into base into height. Base is 5, height is 4, so that will be equal to 10. Area A2, or rather I'll just write A3 first. A3 is half into base is 5 only, height is, so the coordinate of P is 1 comma 1, height will be 1. It will be 5 by 2, that is 2.5. P2 is half into 4 into 1, it is equal to 2. A1 will have A minus A2 minus A3, that is 10 minus 2 minus 2.5, that is 5.5. Okay. The coordinate of P in triangular coordinate system, it could be A1 upon A2 upon A3 upon A, that is equal to 5.5 upon 10, 2.5, 2 by 10, 2.5 by 10, that is equal to 0.55, 0.2 and 0.25. Yeah. Rafael has written something. For the third, we see 1 by 4 is relationship for heights. For the third,
It does not correspond to your solution. Just the relationship for areas is the relationship for heights of the triangle, so we can see that 1/3, 1/4 for A3. Just fast solution.
are you talking about A3?
Yes, in the lecture there was a point we can use a relationship for heights of the triangle. So the coordinates is a relationship for heights, and A3 height is 4 is 1, and the height of the triangular A is 4. So corresponding heights. I use this. I found it useful to use a relationship for heights in this problem.
Still didn't get it.
Yes,
Okay.
actually, he means like the triangle in front of the point 3, not 3, A3. We can just make a ratio between the heights. The height is 1 for P for the smaller triangle to the total height, which is 4. It's 1 by 4. So it's 0.25, which is the last triangle. Also for the node number 2, the triangle that is in front of point number 2, the height is 1 by 5, which is 0.55. The third triangle would be 1 minus the sum of the two other triangle, which will be 0.2.
Okay. In that way. Okay, it's your convenience. You guys go for it. Let's say S3 batch. Yeah. Okay. Got it. So let's move on to the next question. This was also discussed. Uh, so there's a question is Lagrange polynomial are used for polynomial interpolation. Suppose we have coordinate for 6 points. Those points can be connected to form a fifth order polynomial such that y equals Lagrange polynomial can be fitted to prepare the fifth order polynomial in such a way, and this is the way. Realize Lagrange polynomial. What will be the polynomial L2 corresponding to point x2, y2? Yeah, you guys have given the answer as option C. It's quite correct. X minus x naught. So if I substitute x2, y2 in this, x2 in this uh, answer, we should get value equal to 1. And for other xi, we'll get value 0. Yeah. So what if I change my question and ask about L4? So what will be the changes? For L2, I got x minus x naught, x minus x1, x minus x3, x minus 4, x minus x5. Oh, Rafael, you want to give answer? You can go for it.
For L4, we should have we should have x1 minus xi in the denominator, and p. Okay, I can use I can name all bricks x minus x on x0, x minus x1, x minus x3, x minus x3, x minus x5. There's no
What
x4.
about x2?
X cube there is there. X cube is there.
What about x2?
X2 is there.
Yeah.
X4 is not there.
Okay.
There should be x5.
Yeah.
The idea here is x minus x4 will give us 0 in the denominator. X4 minus x0, we just substitute x for x is 4 here.
Yeah. Okay. You got it correct. So if we just substitute in L4 x4, we'll get 1. While for other L4, like for x1, x0, x2, we'll get 0. It's not x1, x2, x3, x5. Yeah. Okay. Next question. Consider the following 10-node cubic triangular element and find the shape function corresponding to different nodes. So what will be the shape function corresponding to node 5? Here we have this. I'll give you guys a bit of time if you guys can give the answer.
The answer is B here, but it's interesting question here. You know?
You're saying and oh, okay.
For this question, my question for that type of question, is this function defined in a unique way? Because it seems that we can define this polynomial in a not unique way.
Unique way in the sense?
Unique way for this particular solution, we are choosing the following lines here. Look, for L. Can you a bit zoom it? I don't see the numbers. Okay, for this we should have L1 is equal to 0 line. We need to have L1 is equal to 0 for
Okay.
L5.
Okay. Yeah. Great. L1 equal to 0.
Okay,
So
L1 is equal to 0. Can you draw it?
yeah, this one.
For this L5, we also choosing a line L2 is equal to 0.
L2 equal to 0 is this one. Yeah.
And we end up with 4 and 7 here. 4 and 10. 4 and 10.
10. Yeah.
Solution. The answer to obtain a correct answer, we need to use line L1 is equal to 2/3. Okay.
L1 equal
L1
to
is L1 is equal to 2/3.
2/3.
Yes.
That will be equal to this.
Yes.
Yeah.
And for this also solution, we also need to have L2 is equal to 1/3.
L2 equal to 1/3. So that will be equal to this.
The 4 should be there, I believe.
I also believe like only this two would have been
So
sufficient.
my question is, for my point of view, we can only use L2 is equal to 2/3. Why we connect L1 is equal to 2/3
Equal
here?
to
We can use we can use only L2, and therefore this is my question: is this polynomial defined in a unique way or not? Because if we are using L2, it will be enough for me.
I do feel like answer should be just involving L1, L2. Like L1 is equal to 0, L2 equal to 0, and L2 equal to 1 by 3.
No,
It should,
this is not correct.
let me see. 'Cause it, wait,
Ah, you
cause
you will not have a okay.
secure.
Try you in your way. Use your time to ensure that it is not correct.
Okay. So let's. What I was feeling is answer should be one thing is, let's say, mm, L1 equal to 0, so that is L1 minus 0, L2 minus 0, and the thing I was feeling was L2 minus 1 by 3. This one I was feeling L2 minus 1 by 3, yeah, and we have the coordinate of node 5 L1, L2, L3 as L2 is equal, L1 is equal to 1 by 3, L2 is equal to 2 by 3, and L3 is equal to 0. Okay, so this would be 1 by 3 minus 0. This is 2 by 3 minus 0. This is again 2 by 3 minus 1 by 3. This is what I was feeling should be the answer. L1, L2, 3L2 minus 1 uh, upon 3 here. Now here 1 by 3, 2 by 3, and this is 1 by 3. So this cancels out. So this would be 9 by 2, L1, L2, 3 L2 minus 1. This should be the answer which I was filling. 9 by 2. And none of the options matches.
You okay? I also this is my first solution,
Yeah. I
but
thought this would be.
this was my first solution. But after that, I thought that they also choose the line as I said, L1 is equal to 2/3. If you add L1 is equal to 2/3 here, can you just add with
Okay.
another color
Yeah.
to your
Let's try different way. Yeah. L1 minus 0, L2 minus 0, L2 minus 1/3, and L1 minus 2/3. Right.
yeah, yes.
So this would be 1/3 minus 0, 2/3 minus 0, 2/3 minus 1/3, and L1 is 1/3 minus 2/3. So this would be L1, L2, 3L2 minus 1, and 3L1 minus 2. Divide by 2, 3 is 9. Here 1/3, 2/3, 1/3, and this is also 1/3 but minus. So this would be equal to L1, L2 minus, because in the down it's minus, I'll use here 3L2 minus 1, 3L1 minus 2, 9 cancel out, and 9 by 2. Yeah. Minus 9 L1, L2, 3.
Sorry. Can you again check? Okay.
Actually, the
But
answer should be have L3, and if we are using this way, we will not get L3 in the answer. So for me also, I didn't get the answer
Okay,
unless
okay.
I substitute L1, L2, L3 in the options.
sorry. Can I definitely I definitely find this line. Now I will say let me look at my notes.
Okay. Uh, in this aspect, it's better to use the second way, or like using the elimination rule. That's like most quickest one. Okay, I'll first use that thing. So if I substitute L1, L2, L3 is equal to 1 by 3, 2 by 3, 0, I should get the value as 1. 1/3, 2/3, 0. I should get the value as 1.
Look,
So if
for the 10,
this is 0,
use
this is 0.
L2 is equal to 1/3. Okay.
Hmm?
For the to eliminate 10, you use the line L2 is equal to 1/3.
You're saying L2 is equal to 1/3. This is L2 is equal to 1/3, right?
No. L3 is equal to 1/3. Sorry.
Okay. Now
Can you
you
show this line?
okay, so this is equal to 0. This is L3 equal to.
Yes, this line.
Okay, so now what lines you are considering? L1 equal to 0, L2 equal to
L2 is
0,
equal to 0, L1 is
uh,
equal to 2/3,
2/3, and L3
L3 is
equal
equal
to
to
1
1/3,
third.
yes.
Okay, so you are not considering this line, yeah?
Yes. It was so
No, but if we see, uh, do like this,
look,
node 4.
I waste a lot of time to find this line, and after that I just choose the wrong option. It was very frustrating for me because I definitely with this you can ensure yourself that this produce a correct line here, correct answer.
Okay, okay. First thing first, let me do the second way and let me see which one is the correct answer first. Okay. Uh, so if I substitute 1/3, 2/3, 0, first and fourth we can eliminate. Let's see what is the value here. So this is
This I also checked. For b is equal to 1, it will be 1.
1. Okay, let me see. L1 is equal to 1/3. So that is 1 minus 2 minus 1. L3 is 0. So minus 1 that gets plus 9 by 2 L1 L2. Okay, that's one. Similarly for option C, uh, L1 L2 3 L2 minus 2. 3 L2 minus 2. This is L2 2 by 3. This is 0, right? 2 by 3, 2 minus 2, 0. Yeah. So we can say for sure that option B would be the answer by using elimination rule. Now need to see why. So if I see the answer, lines involved are L1 equal to 0, L2 equal to 0, L1 equal to 2 by 3, and L3 equal to 1 by 3. Okay, let me draw those lines. So L1 equal to 0 is this line, L2 equal to 0 is this line, L1 is equal to 2 by 3. L1 is equal to 2 by 3 is this line, and L3 is equal to 1 by 3 is this line. So this covers all the nodes except node 5. So that is correct in one way.
What can you say about this question? About uniqueness?
So seeing this, I feel uh, that it won't be unique.
I noticed
Because
that is not unique.
because I didn't see the options. I was certain that I would get this answer, but after looking the options, I came to know that yeah, it won't be unique. Okay, so L1 equal to 0, L2 equal to 0, L1 equal to 2 by 3, and L3 equal to 1 by 3. Oh, this one only you said, huh?
Can you agree that this is not a really well formulated question?
It could have been like multiple choice question, like if all the options were there, like this, and again answer coming out to this, then the elimination rule won't be easy.
Okay. These tricky questions will be very difficult during the exam.
Yeah, I do feel yes, but I don't think they will give this much complicated stuff. It's better to use elimination rule. My suggestion would be that only. Okay, let's move on to the next question. I'll just write this one. Say 5 L1 minus 0, L2 minus 0, L1 minus 2 by 3, L3 minus 1 by 3, L1 minus 1 by 3, 0, L2 is 2 by 3, 0, 1 by 3 minus 2 by 3, and L3 is 0. You'll get what the answer is. Okay, next
Yes.
question is what will be the safe function corresponding to node 10? I don't know, like, is it the same way? The
No,
trickiness
no,
is in one.
this is really easy, and we have already solved this in
Okay,
previous session.
L1 equal to 0, L2 equal to 0, L3 equal to 0.
Yes, yes, yes.
So it was this, I think. Yeah. Right. Okay. Moving on to the next question. Question 19. Suppose you want to construct a 8-node serendipity element. What will be the approximation function to be used to construct the safe function? Eight node serendipity element.
8-node serendipity element consists of 8 constants.
1 x y x square x y y square x square y x sorry, x cube x square y x y square y cube. I don't need further or I'll just write it. So x cube y x square y square x y cube y 4. So we need 8 nodes. So 1, 2, 3, 4, 5, 6. Then we need to select 2. So what should be x cube x square y or x square y xy square xy square y cube or x cube y cube? Yeah, said option C. Yeah, so we include this option C. Yes, yes. So C not x square x y square x square x y. Yeah. Mm, it should be symmetric. Yes, Rafael, you are correct. Okay, last question for today's session. Consider a quadratic triangular rectangular element and find the safe function of node 9. Node 9 with coordinate minus L by 2, comma 0. Node 9 is here.
Abdullah has
Guys.
a question.
Oh, okay. Regarding the previous question, I say
Yes, actually, my question is, could it be not symmetric?
no, it should be symmetric because if we don't use symmetric, suppose I take the elements as x cube x square y, right? Like this thing. So if you see the dominant thing is more towards x. So if unless there is a question stating that there is a dominance in one direction more in x compared to y, you need to take it as a general element that there is no dominant thing. Both are both are equivalent. If you
So
see, yeah,
is there any kind of situation that needs to be dominated by x or by y, so we can use x cube and exclude xy squared?
like suppose you have this kind of element, six-noded element. I'm just saying six-noded element. So in this, there is a quadratic in x, but there is a linear behavior in y. If you see, so suppose if my question was 1x x square y x square x y square till here, the six noded, right? 1 2 3 4 5 6, 1 2 3 4 5 6 3 3 6. Okay, so this will complete as a whole. But if there had been a case, uh, I of a certain, mm, where x dominant need to be taken, like if I take, if x is equal to something, c0 plus c1x plus c2x square, c2y plus c3x square plus c4xy plus c5y square. If I take x, y to be constant, my fx, this safe function, should have a quadratic in nature. While on the other hand, like if I take x as constant, for this element, I took a general element and I substitute in this safe function. So it should come out to be a linear in y. If it is coming out to be quadratic, then it's round. So as in general, we want this thing to be symmetric.
Okay, thank you. I think I got something.
I believe if we already had this discussion a bit in previous sessions. If some characteristics requires high order polynomial along x, for instance, boundary elements consist of q distributed load with x square order. If we want to take this with serendipity element, we can assume, I believe,
We
asymmetry here.
discussed in that regard, like how that numerical integration we will
Yeah.
use. Okay. Okay. Moving on to the last question of this session. Consider a quadratic rectangular element and find the safe function of node 9 with the coordinate minus L by 2 comma 0. I hope by this time you guys have already calculated. If not, I'll give some time. Meanwhile, I'll do mine.
Again, if we want to use a fast way, we just substitute x is equal to minus L over 2 and y is equal to 0.
Minus L by 2 comma 0. Okay, I'll write it here.
Sorry. This elimination will not cannot work because we can end up with two functions that is equal to 1.
Then we can substitute other also. X equal to 0, x equal to L by 2. So first substitution is minus L by 2 comma 0. Right. So it should give my value equal to 1. So if I substitute x equal to minus L by 2 here, x equal to minus L by 2. This is giving me a complex. I'll just look somewhere. If I substitute it here,
You have
here
y is equal to h
0,
there.
0, and L by 2 0. Oh,
I
sorry.
believe it
Sorry,
should
sorry,
be
sorry.
you should have wrote
Minus
you should
12.
have written y is equal to h over 2, not h. I see that
I
you wrote
didn't.
y is equal to h there. The
Oh, okay, 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 okay. Thank you,
yeah.
thank you. Yeah. So on substitution of this uh, x equal to minus L by 2, this is L square h square minus L by 2 minus 2L 4h square. So this is complex minus L by 2. This is minus 2 minus 5 by 2L 4h square. So this won't be giving me any way value equal to 1, right? It won't be equal to 1. This one 8 minus L by 2 L square h square minus L by 2 will give me minus L, and this is h square. So this is minus 2L, and this 2 get cancelled out. It gave me L square h square L square h square. This is equal to 8. Then same thing minus L by 2. So this would be minus L by 2. So as a whole, this would be L by 2. L square h square. This will be minus L by 2. Then this will be minus 2L h square. This will give me minus 1. And the last one minus L by 2 L square h square minus 2L h square 1. We get it directly by elimination itself.
Okay, you're a liker.
Okay, now more the traditional approach quickly. So I don't know if here also there is a multiple answer. What, I don't think so.
No,
But x
here we have one
uh,
answer.
okay, x this one x is equal to 0 line, x equal to L by 2 line, y equal to minus h by 2, y equal to h by 2. So x minus 0, x minus L by 2, y equal y minus h by 2, and y plus h by 2. And substitution is x is equal to minus L by 2, and y is equal to 0. Okay, so this is x to x minus L by 2 here, then 2y minus h by 2, and 2y plus h 2, and here minus L by 2. This is minus uh, minus L minus L, then minus h by 2 and h by 2. This is equal to x, 2h minus L, 2y minus h, and 2y plus h. This will give me 4y square minus h square by 8, and this gets cancelled out by down. Then this is minus L square h square. This is equal to x, 2h minus L h square minus 4y square L square h square. Okay, done. Okay, this concludes today's session. I don't think you guys have any doubt regarding this solution of assignment 10, and hope you guys have got some idea to the questions relevant to assignment number 11. Okay.
A very difficult week, by the way.
Yeah, I myself feel a bit undermined in this lecture. So best of luck to you all.
Whole lection is 50 minutes long with very difficult derivation. It's difficult to follow.
Mm, okay. Okay, can we end the session now? If you guys have any other problem.
Yes, sure. Thank you very much for your time.
Okay.
Thank you
Thank
for
you.
your time.
Thank you all to join us. And see you in the next weekend. Same time.
Same time, it means Sunday again.
Yeah. Sunday 10
Okay.
to 12. If it's fine with you all.
Okay, thank you.
Yeah. Okay. Bye. Good night. Take care.
Good night.
Good night.